Okay, so for this problem, we are asked to give the coefficients in part A for water and pH plus, and in part B, we're asked to give coefficients for water and OH minus. So, difference between part A and part B is that part A you have to balance the redox reactions using acidic reagents, and in part B you have to balance it using basic reagents. Okay, so I'm going to go through both steps, both ways to do it step by step, and hopefully it helps you out. Alright, so for part A, you first have to balance the half reactions. So full reaction is this. Now, if you can identify the reducing agent and the oxidizing agent, that's great because that'll help you see where the electrons are going on either side of the equation. But that might be great and all, but ultimately what you have to do is you have to balance the half reactions first, because you have to make sure that the charges on both sides are the same. So we're going to first do the IO3 minus with the I minus. Okay. Alright, so if you can see here, there's 3 oxygen atoms on this side of the equation. There's just the iodide anion on this side, so we have to add water to this side, because that's how you balance the oxygen out, right? But now that there's water, there's oxygen and hydrogen, so you have to add H plus to this side to balance out the hydrogen from the water on the other side. Okay, so now we can balance the equation. So we've got 3 oxygen atoms over here. Then we have 6 hydrogen ions over here. Okay, so now we have to balance the charges. So we've got a -1, and then we have a +6. So that gives us +5 on this side. We have a -1 and a 0. So that gives us a -1. So in order to balance this equation, in order to balance this equation with charges, we can only add electrons to one side of the equation. And can you figure out which side it is? You can only add minus. You can only add to the positively charged side because this side already has a negative charge. Alright, so how many electrons would we have to add to the +5 charge to equal a -1 charge? We would have to add 6 electrons. Okay? Alright. Now to balance the other half reaction in the equation. Tin on this side has a +2 charge, and tin on this side has a +4 charge. That means that essentially what happens is tin is getting oxidized because it's losing electrons, gaining a higher oxidation state. And so what that means is we have to add electrons to the product side of the equation because tin has essentially lost electrons. How many has it lost? Well, it's lost 2 electrons because 4 plus and 2 plus are the same when you add -2 to the 4 plus. Alright? Now, this is all fine, except in the previous reaction, we had a total of 6 electrons, and in this reaction, we only have a total of 2. So that means that we have to multiply the entire equation by 3. So that we get this as our final half reaction. So now, if we want to add both of the half reactions, just write them out. Then we would add 10. And so now we can add both reactions. Now we can cancel out the electrons, and there's your complete reactions for you.